Hello students, in this video we're going to learn about how to find length of an arc of a circle and also how to find the area of a sector. Right now this is part of IB/DP Math SL syllabus, which comes under, and this comes under circular functions in trigonometry. Right? Okay. Now before we proceed further, we have to learn about radian. Now what is a radian? Now radian is actually a unit of measurement of angle. Now till now you've been using degrees, isn't it, to measure angle, to represent the measure of an angle. Now we can also use radian. Of course there is one more thing called grade, but that is not in your syllabus. So let us learn about radian. Now what do you mean by radian? Okay, what is 1 radian? Okay, let me draw a circle, center at O. Okay, let me take the radius as R units. Okay, R. Now you can see an arc, minor arc AB. Okay, now suppose if, now you can see that this arc AB subtends an angle at the center, isn't it? Okay, now if it so happens that if the length of this arc AB is also equal to the radius of the circle, then this angle is defined as 1 radian. We write it as 1 par c. We write degrees as 1 par 0. Here we write it as 1 par c. Okay, so 1 radian is nothing but angle subtended by an arc. You can see this arc at the center of the circle, provided the length of the arc is same as the radius of the circle. Okay, so that is 1 radian. So what it means is, let me construct another circle for you, and let us say let this be R, and in case if this arc length is 2R, then the central angle, the angle it will make at the center, is nothing but 2 radian. Okay, if the arc length is R, 1 radian central angle. If the arc length is 2R, then 2 radian. Okay, let me construct another circle for you. Okay, let us say this is the center, and then, sorry, I think it's the center, and let's say if this arc length, okay, let's say this is RR. If this arc length is 3R, then the central angle, this angle that you see here, is defined as 3 radian. So 1R makes 1 radian, twice the radius makes 2 radians at the center, thrice the radius makes 3 radians at the center. Fine. So let us consider these 4 circle students. The first one, this one, the length of the radius is A units, and the arc whose length is A subtends 1 radian at the center, right? Now if you look at the second one, the second circle, the arc length, that is this one, is 1.5 times radius. So the central angle is 1.5 radian. Now in the third diagram, the arc length, the major arc, the arc length is 4 times c, which is 4 times the radius. So the central angle is 4 radians. And in the fourth circle, you can see this arc length, the minor arc, the length of the arc is twice the radius. So the central angle is 2d. So can you see any pattern, students? Do you see any pattern? You can see that the length of the arc divided by the radius gives you 1. Here the length of the arc, so 1.5b divided by the radius b gives you 1.5. So here also the length of the arc 4c divided by c, the radius, gives you 4. And then here length of the arc 2d divided by d gives you 2. So from this it is very easy to deduce that if the radius of the circle is R units, if the central angle here is theta radian, and the length of the arc is, let's say, L, then you can easily say that the length of the arc divided by the radius will actually give us the value of theta, isn't it? So we get L equal to R times theta. So this is the formula to find length of an arc of any circle provided the radius is given and also the angle made by the arc at the center of the circle is also given. Now it is very important to note that this angle should be in radian, students, okay, not in degrees. In case if it is in degrees, then there is a different formula which we shall derive later. Okay, fine. Okay, look at this circle, students. You can see I have drawn a sector here, which is bounded, sector OAB, which is bounded by the radius OA, the arc length, the arc AB, the minor arc, and also the radius OB. Okay. Now let us say the radius of the circle is r units, and the central angle is theta radian. Okay. What if I want to find the area of this sector? That means I want to find the area of this shaded region. Okay, how do I find that? Now we can use unitary method. Now what it means is, for example, we know that the central angle, this angle that you see, the central angle is 2 pi radian, isn't it? So if the central angle is 2 pi radian, then we know that the area is pi r square, isn't it? The area of the circle is pi r square. So now I would like to know, what if the central angle is theta radian? Then what will be the area? That area will be the area of the sector, isn't it, students? Okay, how do I find that? Now from this, if 2 pi radian gives you pi r square, then 1 radian will give you an area which is equal to pi r square divided by 2 pi, which is nothing but r square by 2. Fine. 1 radian will give you an area, will give us an area of r square by 2. So hence theta radian will give us an area of r square by 2 multiplied with theta. So basically, which is nothing but half r square theta. So this is the area of the sector. So this is the formula, we have derived the formula to find the area of a sector. So area of a sector is nothing but half times square of the radius multiplied with the central angle in radian. Okay, fine. Fine. So if theta is in radians, and provided they have given the radius of the circle, then the length of the arc is given by L equal to r theta, and the area of the sector is given with the formula A equal to half r square theta. Now the question is, what if the radius is given, but the angle, central angle, is given in terms of degrees, not in radian? Then what do we do? Okay, so let us derive a formula for that. Okay, consider the circle, students. They have given the radius is r units and the length of the arc, minor arc AB, is L, represented by the letter L, and the central angle is given in degrees, theta degrees. Then how do we find the length of the arc? Okay, again we use the unitary method. If the central angle is 360 degrees, then the arc length will be 2 pi r, isn't it? Which is basically nothing but the circumference of the circle. So 360 degree will give us 2 pi r, which means 1 degree will give us an arc length which is equal to 2 pi r divided by 360 degrees. Okay, 360, sorry. So we are interested in finding, then what will theta degree give you? What will be the length of the arc if the central angle is theta degree? Then you just have to multiply this expression 2 pi r by 360 into theta. So the answer is theta divided by 360 into 2 pi r. So this will give you length of the arc. Okay, this is the formula to find length of the arc. Okay, in the same window, let us try to find the area of a sector. Now, if the central angle is 360 degree, then it will give us an area which is equal to pi r square units. Pi r square units. So 1 degree will give us an area which is equivalent to pi r square equal to pi r square by 360. But I am interested in finding the area of the sector, and the sector has theta degree at the center. So theta degree will give us pi r square divided by 360 multiplied with theta. So which is nothing but theta divided by 360 into pi r squared. So that is the area of the sector if the angle is given in terms of degrees. Okay, I hope the concepts are clear. So let us start solving some problems, students. I hope you have taken the worksheet. There are 7 problems in the worksheet. I'm going to solve each one of them, so it is better that you have the worksheet with you right now. Yeah. So let us start doing the first problem. Fine. Let us look at problem number 1. Now you can see the diagram shows 2 concentric circles with center O. Okay. Concentric circles in the sense both the circles have the same center. The radius of the smaller circle is 8. It is written in blue color, and the radius of the larger circle is 10 centimeter. Points A, B, and C. Okay, the point A is here, B is here, and C is here. Points A, B, and C, and sorry, I think B is this is B. This is B, and this is C. Draw the circle. This is C. Points A, B, and C are on the circumference of the larger circle such that angle AOB is pi by 3 radian. You can see the angle at the center. The first question is find the length of the arc ABC, ACB. So the first part is I want to find the length of the arc. We know the formula is r times theta, so which is nothing but 10 times pi by 3. So you have to use your calculator, and please make sure that you write the answer correct to 3 significant figures, students. Okay, it's very, very important. Now next part is B. Find the area of the shaded region. Now you can see here I have shaded the region using this gray marker. Okay, so you need to find the region. Now it is very easy to find out. Note that this particular part, the gray, region which is shaded in gray, you can easily find that area by finding the area of the larger sector. That means this one. Find the area of this sector, and then you find the area of the smaller sector, and then subtract. Right? That will give you the area of the shaded region. So area of the larger sector is half r square theta. That means half multiplied with 10 square into pi by 3, and then the area of the smaller sector is half of 8 squared into pi by 3. Then you subtract, that will give you the answer. Okay. Now it is always advisable to write both these expressions, this and this, in the calculator and then find the answer, students. Normally what you do is, what some of you do is, you find this expression first, then you write down the answer, then you find this separately, then you write the answer, then finally you subtract. And that is not the, to be honest, that is not a good way to do it. So you have to type both these expressions in the same window in the calculator, and then whatever answer you're getting, you have to round it off to 3 significant figures. Okay, so I hope this is clear. Fine. This is problem number 2, students. The circle shown has center O and radius 3.9 centimeter. Points A and B lie on the circle, and angle AOB is 1.8 radians. So the first question is find AB. Now they are not mentioned find the length of the arc AB. They have mentioned that find AB, which basically means we need to find the length of this line segment. We need to find the length of this line segment, and as you can see, this is also 3.9. So we have 2 sides and an included angle, so we can very well use the cosine formula. So as per the cosine formula, we get AB squared equal to 3.9 squared plus 3.9 squared minus 2 times 3.9 into 3.9, which is 3.9 square, multiplied with 1.8. Okay, so AB is nothing but square root of this expression. Okay, so you put this in a calculator and get the answer. In fact, I made a small error here, students. I'm sorry for that. It was an oversight. So it is not 1.8. So you need to multiply cos 1.8, isn't it? So basically you'll get 2 times 3.9 squared multiplied with cos of 1.8. Okay, now before you enter this expression in the calculator, please make sure that the angle is in radian mode. Okay, otherwise if it is in degree mode, you will get incorrect answer, so obviously you will not get full marks. So if you enter this expression in the calculator, you will get 6.1099, so basically which is nothing but which is approximately equal to 6.11 centimeter. So that is the answer for A part. Now the next one is B part. Find the area of the shaded region. Now this is the shaded region. That means you can see the major sector. Okay, this is the major sector. So the question is find the area of this major sector. Now you can easily find the answer by finding the area of the circle, and then from that you can subtract the area of this minor sector. You see the minor sector here. You find the area of the minor sector, subtract it from the area of the circle. That will give you the area of the shaded region. So the answer is area of the circle is pi r squared. So pi times 3.9 squared minus area of the smaller sector is half times 3.9 squared multiplied with 1.8. Okay, so this is the answer. Okay, this is problem number 3, students. The following diagram shows a circle with center O and radius 4 centimeter. The points A, B and C lie on the circle. The point D is outside the circle on OC, the line segment, the extended line segment OC. Angle ADC is 0.3 radian. I have written it in green color. And angle AOC is 0.8 radians. Okay. The first question is find AD. So basically, which means the length of the line segment AD. Now we can use sine rule here, isn't it, students? Like we have the OA. So we need, when we have two angles, so we can use sine rule. So sine, according to the sine rule, we have AD by sine 0.8 will be equal to OA, which is 4 divided by sine 0.3. Okay, so again please make sure that the angle is in radian, the input mode, and you can find AD. If you use the calculator, you'll get this answer. So you'll get 9.7097, so approximately 9.71 centimeter. So that is length of AD. So now the next part is find the length of OD. Okay, now we have the length of AD and length of OA, and we need to find the length of OD. We can use cosine rule here. Okay, so what I'm going to do is I'm going to find, so for using the cosine rule, I need two sides and the included angle, right? Now I have OA, which is 4, and I have AD, which you have just found, which is 9.71. So I need this angle. Okay, you can see that some of the angles of a triangle is 180 degrees. That means pi radian, isn't it? So to find that angle DAO, the answer is pi minus 0.3 minus 0.8. So if we enter this expression in the calculator, we shall get 2.04. Okay, now I can use the cosine rule. So OD square is equal to, you get 9.71 squared plus 4 squared minus 2 times 9.71 multiplied with 4 multiplied with cos of 2.04. So you shall get 12.058, which is approximately equal to 12.1. Okay, so OD will be square root of this expression 12.1. Okay, now let us do the C part. So we are required to find the area of the sector OABC. So that's very straightforward. The area of the sector is half times the radius square, which is 4 square, multiplied with theta, which is 0.8. So that will give us the area of the sector OABC. Finally, we are supposed to find the area of the region ABCD. That means this part. Area of this region. So that is nothing but area of the triangle OAD minus area of the sector OABC, isn't it? So area of the triangle is, we're trying to find the area of this triangle. Area of the triangle, this triangle. So that is half multiplied with product of two adjacent sides, which is, let's say 4 and 9.71, multiplied with sine of the angle between them, which is sine of 2.04. So this will give me the area of the triangle. Now I'm going to find the area of this sector, this sector, which is this expression, isn't it? So minus half multiplied with 4 squared into 0.8. So if you enter this expression in the calculator, you will get an answer. That is the area of the region ABCD. Fine. This is the fourth problem, students. The diagram below shows a circle with center O and radius R. The length of arc ABC is 3 pi. So that means this one. The length of this arc is 3 pi centimeter. And the central angle is 2 pi by 9 radians. So the question is, find the value of R. So subdivision A. So we know that the length of the arc is given by the formula L equal to R theta. So we have 3 pi equal to R into 2 pi by 9. So which will give us R equal to 13.5. If you simplify, you will get 13.5 as an answer. And the B part, find the perimeter of the sector OABC. So they're talking about this sector, this OABC, which is very easy to find. The answer is R plus L, isn't it? So which is nothing but 13.5 plus 13.5 plus 3 pi. Okay, so you please enter this in your calculator and write the answer in decimal number, as a decimal number. The C part is find the area of the sector OABC. Again, straightforward question. So the answer is half multiplied by R square, which is 13.5 squared, multiplied with theta, which is 2 pi by 9. Okay, so it's quite simple, isn't it? All this, in fact, the problems based on these concepts are normally quite simple, students. You have to just apply your mind a little bit, and you shall definitely be able to get it correctly, get the correct answer. Fine. So let us look at the fifth problem. Okay. So here it's mentioned the following diagram shows a sector of a circle of radius r centimeter and angle theta radians at the center. The perimeter of the sector is 20 centimeter. So basically it means, if I take this as L, R plus L equal to 20. Okay. So the first part is, you have to prove that, you have to show that theta equal to 20 minus 2r by r. Now how do we show that? So let us take this expression. You can see that there's a 20 here, so obviously I have to use this expression. So I can write this as r plus, instead of this L, I can write r theta, isn't it? Because we know that the length of the arc is r theta, so equal to 20. So basically you get 2r plus r theta equal to 20. So r theta is 20 minus 2r. So you'll get theta as 20 minus 2r divided by r. So very simple and straightforward. Now subdivision B. The area of the sector is 25 square centimeter. Find the value of r. So it's given half into r square into theta equal to 25. Now what I'm going to do is, instead of this theta, I'm going to substitute this expression. So I get half multiplied with by r square into 20 minus 2r by r equal to 25. So I can cancel an r and r. I can take the 2 to the other side, so and multiply this and this. So you'll get 20r minus 2r square equal to 50. So you'll get 2r square minus 20r plus 50 equal to 0. If you solve it, it's a quadratic equation, you get r equal to 5 or 5. So hence the radius of the circle is 5 centimeter. Right? So let us go to the problem, sixth problem now. Fine. The following diagram shows a circle with radius r and center O. The points A, B and C are on the circle and angle AOC is theta. The area of the sector OABC is 4 by 3 pi, 4 by 3 times pi, and the length of the arc is 2 by 3 times pi. So it's given the length of the arc L equal to 2 by 3 times pi, and the area of the sector capital A is 4 by 3 times pi. So using these information, you have to find the value of r and of theta. Okay. So how do we do that? So first let me take this L. So this will give me r theta equal to 2 by 3 times pi. Correct? Okay, I'll leave it as it is. Then I will take this A. A is nothing but half r square theta equal to 4 by 3 times pi. Okay. So what I'm going to do is I'm going to rewrite as half r into r theta equal to 4 by 3 pi. There is a reason for that. Now what I'm going to do is I'm going to replace this r theta with 2 by 3 pi, isn't it? I mean both of them is the same. So 1 by 2 r into 2 by 3 pi equal to 4 by 3 pi. So if you simplify, you'll get r equal to 4. So the radius of the circle is 4. So from that you can very easily find the central angle. So 4 times theta, r theta is 2 by 3 pi. So which gives us theta equal to pi by 6. Right? So radius is 4 and theta is pi by 6. Okay. So let us look at the last problem, problem number 7. Fine. The diagram below shows a circle of radius 5 centimeter with center O. Points A and B are on the circle and angle AOB is 0.8 radians. The point N is on OB, the line segment OB, such that the line segment AN is perpendicular to the line segment OB. Okay. So the question is find the area of the shaded region. So this is the shaded region. I'm shading it using the gray marker. So how do we find the area of the shaded region? So what you can do is you can find the area of the sector OAB, okay, and then find the area of this area of the sector. Let me sketch it. Area of this sector, and then you can find the area of this circle. Sorry, I'm sorry, triangle, not circle. I'm sorry. Find the area of the triangle, and then subtract. You will get the area of the shaded region. Okay, but to find the area of the triangle, I require, they have given only, it's a right angle triangle, yes, but I have only an angle and hypotenuse. So I need one more side. So what I can do is I can, let me just draw the right angle triangle here. So it looks like this. So this is A, this is N, and this is O, and this is 0.8, this is 5, the hypotenuse is 5. So I can find ON. So cos 0.8 is equal to ON by 5. So ON is nothing but 5 times cos 0.8. So which is nothing but approximately equal to 3.48. So 3.48. Okay. So from now you can easily find the answer. The answer is area of the sector, which is nothing but half r squared, which is 5 squared, into theta, which is 0.8, minus area of the triangle is nothing but let me use the blue color. So half multiply with the two adjacent sides, which is 5 and ON, which is 3.48, multiplied with sine of the angle between them, which is sine of 0.8. Okay, so if you type this expression in your calculator, you will get the correct answer. Okay, so fine, I think we have done all the problems in the worksheet. So I hope this concept is clear, students, right? So I hope this you have found this video helpful. Fine, see you in the next video then. Yeah, thanks for watching. Thanks for watching this, students.